Hello everyone, I'm Kuromeru. In addition to the transformations we have covered so far, scaling and rotation, we will now introduce translation. With only rotation and scaling, the origin remained unchanged. However, by adding translation, we will be able to handle the movement of the coordinate system's origin. Now, let's get started. We will now extend the method in the previous video. We introduce a third component to an R2 vector and set it identically to 1. For example, the vector 2, minus 1 becomes 2, minus 1, 1. With this notation, the Euclidean group can be represented using matrices as follows. Here, the A part represents scaling and rotation, while the V part represents translation. When this is applied to a vector, it generally transforms as follows. Doubling the vector 2, minus 1, 1 results in 4, minus 2, 1 through the following calculation. Translating the vector 2, minus 1, 1 by x, y equals 1, 2 results in 3, 1, 1 through the following calculation. In this notation, we do not explicitly write the base point of the vector. However, we assume that the base point also moves under translation. Let's apply the knowledge from the previous video, where we performed transformations in sequence. We will first translate by 1 unit in the x direction, and then scale by a factor of 2 around the new origin. All the information about this transformation will be contained in an element G of the Euclidean group. If we denote the translation in the x direction as G1, and the scaling by a factor of 2 as G2, then since the translation is applied first, we have G equals G1 times G2. Indeed, when we apply this transformation to the basis vector Ex, which is 1, 0, 1, we obtain 3, 0, 1. Now, why is the new origin at 1, 0, 1, as shown in the diagram? The reason is that when we input 0, 0, 1, we obtain 1, 0, 1. Confirming that the origin has moved accordingly. Similarly, when we apply the transformation to the other basis vector Ey, which is 0, 1, 1, we obtain the result shown in the diagram. This represents all the information contained in G. By replaying the movie, we can see that the transformation indeed behaves as expected. Now, let's try scaling first, followed by translation. Since we applied G2 first and then G1, their composition is as follows. By performing the calculations in the same way as before, 0, 0, 1 transforms into 2, 0, 1. 1, 0, 1 transforms into 4, 0, 1. And 0, 1, 1 transforms into 2, 2, 1. Thus, the transformation results in the following image. Finally, how can we perform scaling by a factor of 2 centered at 2, 0, 1? In this G transformation, we have always observed points based on their values in the original coordinate system. In this case, the yellow point is 2, 0, 1. This means that we need to consider scaling by a factor of 2 in a world transformed by T. In other words, we need to construct Tg2T inverse. Since the transformation G we constructed earlier is given in this way, we can obtain the desired result by considering Tg2T inverse G. And we find that, in total, the result is a scaling by a factor of 4 centered at the origin. Amazing, that's exactly right. That is, we first applied g in the original coordinate system, and then applied g2 in the coordinate system defined by t. In summary, this time, we considered translation that changes the origin. I hope this helps deepen your understanding. That's all for today. If you enjoyed this video, please subscribe to the channel and give it a like. Your support motivates me to keep creating more content. Thank you for watching.